Okay, we need to solve for a multiplication problem and a division problem. All right, so let's do that. We have to we can put this in any order we want to. So I'm going to put the number with the more numbers on the top and then 3.9 on the bottom. So it's less work to do overall, right? If you put the 3 on the bottom, I guess it just ends up being about the same. Anyway, so we have to do 9 times 7, which is 63. So a 6 up there and a 3 here. Okay, 9 times 8 is 72. So we have 72 plus 6, and that gives us 78. So a 7 there and 8 there. 9 times 9 is 81, plus 7 more is 88. Put the spacer, now we're going to do the 3. 3 times 7 is 21, put a 2 here, 1 there. 3 times 8 is 24, plus 2 more is 26. And then 3 times 9 is 27, plus 2 more is 29. All right, then we'll add this up. We have 3 here. 8 plus 1 is 9. 8 and 6 is 14. Okay, and then we have 8 plus 1 is 9, plus 9 more is 18. And then 2 plus 1 is 3. Now let's look up here and see how many decimal places we have to move over. 1, 2, 3 decimal places. So 1, 2, 3. That ends up being 38.493. Okay, so there's the answer to the multiplication problem. So now we're going to have to do the division problem. So the main thing we have to remember when doing a division problem is we cannot have a decimal, okay, in the number that's outside the box. So we moved it over 2 places, therefore that became just a 45. But if you move it over 2 places there, you have to do it here also. So you can see that now the number inside the box, or the dividend, is 314.1. And then I added some zeros. All right, can 45 go into 3? Nope. Can 45 go into 31? No. Can you divide 45 into 314? Yeah, and I'm going to say it's probably going to be about 6 times. 6 times 5 is 30. 6 times 4 is 24. 25, 26, 27. So we don't add those. We subtract that. All right, 4 minus 0 is, and then we have to borrow from here, make this an 11. 7 to 11 is 4 again. All right, then we bring down the 1. So can 45 go into 441? Yeah, probably about 10 times, but not quite. So I would say 9 times. 9 times 5 is 45. 9 times 4 is 36, plus 4 is 40. Okay, we subtract this. Can't take away 5 from 1, so we're going to have to borrow this and make it a 3. So now we have 11 minus 5, and that gives us 6. Okay, then 3 minus nothing is 3. All right, and then we will have to bring down one of these zeros, so it's good that I put one there. So how many times does 45 go into 360? I'd say about 8. 8 times 5 is 40. 8 times 4 is 32, plus 4 more is 36. Perfect. Okay, so this ends up being 0. So there's no remainder. We just bring the decimal up. Okay, so the answer to this one is 6.98. All right, we've solved both the multiplication and the division problem. At the annual hot dog eating contest, Mitchell, I guess, eats 45 hot dogs in 3 minutes. What is Mitchell's unit rate? Okay, so we have 45 hot dogs in 3 minutes. How would we get this down to a 1 minute? Well, we divide by 3. All right, so divide by 3, so this would be 1 minute. And then 45 hot dogs, we're going to have to do the same thing with this one. Divide by 3. So we have 45 divided by 3, which is 15. So 15 hot dogs in 1 minute. So Mitchell eats 45 hot dogs in 3 minutes. What is Mitchell's unit rate? The unit rate is 15 to 1. 15 hot dogs per minute. There's your unit rate. Andrea deposits $138 into her bank account. Okay, so probably the big thing we're going to have to look at is the word deposited. So what does that mean? If you deposit money into or to a bank, that means you're putting money into it. Okay, so you make some money during the week and you deposit it into the bank account. If you need money and you need to take it out of the bank, that would be called withdrawing. Okay, so withdrawing some money. So Andrea deposits $138 into her bank account. Write an expression representing Andrea's bank account. Okay, well, we don't know what's in her bank account right now, so I'm just going to put X for the amount of money that's in the account. And I know that she just put $138 into it. So this would be the amount that's in there. This is how much you added to it. So there you go. That's all you have to do. X plus 3 or 138 would be all you have to do is to create an expression to represent this word problem. Kathy swims at least 6 laps. Okay, she can swim exactly 6 laps or more, right? At least 6 laps. So she does 6 laps, or she does maybe 7 or 8 or 9. It says write an inequality to show how long Kathy swims each day. All right, well, we can just put X for a variable. We know that 6 is the number of laps Kathy swims at least. So we're going to put equals because she might do exactly 6 laps. So I'm going to put the little line like that. And then X can also represent any number larger than 6, right? So it's going to have to be X is greater than or equal to 6 because every day she swims at least 6 laps. So it could be exactly 6 laps, or it could be a little bit more, or a lot more. So X is greater than or equal to 6. Find the rule, solve for N. Okay, well, I think I already see the rule. Do you see the rule? All right, so I'm thinking that each time you're just going to do times 10. Because 3 times 10 is 30. 4 times 10 is 40. 7 times 10 is 70. So then to find what N is, you're probably going to just do 6 times 10. So let's find the rule first. Well, the rule is Y. So this side, whatever number these are, is going to be equal to X times 10. Or you can just put 10X. Okay, so whatever X is, you multiply by 10. And that gives you Y. So there's the rule. So to find for N, we already looked up there. 6 times 10 is 60. So there's our rule. And N equals 60. Luis's coffee table measures 4 feet long, 2 feet wide, and 2¼ feet high. All right, so I went ahead and did my little drawing, and there it is. What is the volume? Okay, so we're going to do length times width times height. All right, so I put it over here. 2 just becomes 2 over 1. 4 just becomes 4 over 1. And then 2 and 1/4, well, 2 times 4 is 8, plus 1 more is 9. So it's going to end up being 9 over 4. All right, so let's see if we can do any cross-reducing before we have to solve it. Yeah, we can definitely do that. We know a 4 goes into 4 once, and a 4 goes into 4 once. And that's about all the cross-reducing we can do. And we could have done it differently, but we're just going to leave it like that. So we have 2 times 1, which is 2, times 9. 9 is 18. And then we have 1 times 1 times 1, which is 1. So it's 18 over 1, which is 18 feet cubed, right? Because it's volume. 18 feet cubed is the volume of the coffee table. Okay, we need to find the mean absolute deviation. Okay, they do love this on the state test, it seems. Mean absolute deviation. A lot of times you'll just see it as MAD, M-A-D. All right, so here's what we're going to do. We have to find the mean first. Well, the mean is the average of all the numbers. So I went ahead and took the numbers and rewrote them from least to greatest. I don't think we really have to do it this time, but it's always a good habit to do that. So we have 4 plus 6 plus 6 plus 7 plus 8, and that's going to equal 31. Okay, so this total is 31. And how many numbers are in the data set? 1, 2, 3, 4, 5 numbers in the data set. So we're going to do 31 divided by 5, and that's going to be 6.2. Okay, so our mean is 6.2. So what we're going to have to do is we're going to have to take each number and subtract 6.2 from it. Okay, so I'm going to rewrite the 8, the 7, the 6, the 6, and the 4. And then I'm going to have to subtract 6.2 from each one of these. All right, so I have it all written out, and I have the little yellow lines because, remember, it's the absolute value. We don't care if it's positive or negative. We just want to know how far it is from 6.2. So 8 minus 6.2 is equal to 1.8. And then 7 minus 6.2 is equal to just 0.8. 6 minus 6.2 is obviously just 0.2, right? 0.2. It's actually a negative 0.2, but we're not worried about that. And then we have another 6 minus 6.2, which is 0.2. And then we have 4 minus 6.2, which is actually a negative 2.2, but once again, we don't care if it's positive or negative. We just want to know how far it is. All right, so now we need to add this up. We have 8 and 8 is 16, 17, 18, 19, 20, 22. So we have a 2 here, and bring that up. 2 plus 1 is 3, plus 2 more is 5, so it's 5.2. So 5.2 when you add all those up. Okay, so we have 5.2 when you add up all of the distances away from the mean. So right over here, we have 5.2 divided by 5, because that's how many numbers are in the data set, right? So we're going to take 5.2 divided by 5, and that actually ends up being 1.04. Okay, so our MAD, or our mean absolute deviation, is 1.4. And what that means is you take the mean, which is this, and it would be very typical for a number to be 1.4 either higher or lower than 6.2 in that data set. Okay, so that's how you find mean absolute deviation. Write this non-statistical question as a statistical question. Okay, so guys, most important part of this is a statistical question has variance. Okay, it varies. V-R-I-A-N-C-E. Okay, has variance. All right, which means it can't just be one answer. So how much money does my teacher make? Well, that's just going to be one number. Okay, so if you're like, hey, Mr. Gunner, how much you make? And I tell you, that's just going to be the amount. There's not a lot of variance to it. So to make it a statistical question, you would have to ask multiple teachers. Just say, how much does each, or well, that won't even work either because it's all going to be the same answer. So it just have to have variance. Like, for example, how much does my principal make? Is that going to be statistical? No, because it's just one answer. How much does my teacher make? No. What is my teacher's last name? That's not going to have variance. But if you ask like 20 kids, what are your teacher's last names? Okay, then that would have some variance. Or what if you ask, what teacher do you think is the best dancer? Okay, is everyone going to pick the same teacher? Nope, so that's going to have some variance. Okay, so there's so many different possibilities. So what it comes down to is as long as it has variance and it's not just one possible answer, that is statistical. If it only has one possible answer, not statistical. Graph the integer 2 and its opposite on the number line. Okay, these are going to be really fast. Okay, here's the 2. The opposite of 2 is going to be the same distance away from 0 on the other side. It's right there. How about this one? Graph the integer 4 and its opposite. Well, here's 4. Okay, go across the 0, go for the opposite direction, the exact same distance. That's it. Sometimes they'll try to trick you and ask you to do the opposite of the opposite, and that just lands you right back where you started. So if you start at 4 and you go to -4, and then you do the opposite of that one, and you're right back there. It's something that they do sometimes for a trick, but anyway, that's how you graph these.